Okay, now what we're going to do is we're going to take the knowledge we learned about geometry in the last video and apply it to solving some problems. Okay? And so in general, what problems involving geometry usually kind of come down to is kind of comparing two different shapes and understanding how they're related, how much bigger one is than the other, or vice versa. Okay? So an example of a problem like this um, is, say you know um, a 9-inch diameter pie takes say 6 peaches. How many would it take to make a 9-inch by 13-inch peach cobbler? Okay, so this is the kind of problem that you can solve with geometry. So we've got here a 9-inch diameter pie, so that means circular, right? If it has a diameter, that means it's circular. That takes 6 peaches, and then we want to know how many it would take to make a rectangular peach cobbler. If you don't, cobbler is just a rectangular pie, basically. So in this question, what we're asking ourselves is really kind of how much bigger is this 9 by 13 rectangle than a 9-inch diameter circle. And then we're going to multiply that number that we get by the number of peaches to get the number that we need. Okay? So the first thing we need to do here is find the area of each shape. Okay? So first the circular pie. So here the area is pi times the radius squared. So the diameter is 9 inches. So the radius is going to be 4.5 inches. And so if we take pi times 4.5 inches squared, we're going to get 63.61 square inches for the area of the pie. For the cobbler, area is easier. It's 9 inches times 13 inches, right? Length times width. And that is 117 square inches. Okay? So 63.61 square inches, 117 square inches. So the cobbler is a little bit less than twice as big as the 9-inch pie, right? Which, again, may seem a little counterintuitive if you think about a 9-inch diameter circle versus a 9 by 13 rectangle. Doesn't seem like that should be twice as big, but in fact it is. Okay? That's why we have to use these carefully. So now what we're going to do is we're going to use these two areas and the number of peaches to figure out how many we need for the cobbler. Okay? So I'm going to erase these because I'm running out of space. But we'll use both these numbers. So we know that it's 6 peaches per 1 pie. We know that 1 pie is 63.61 square inches. And we know that our rectangular cobbler is 117 square inches per 1 cobbler. Notice that I've set this up doing dimensional analysis. Notice that I've taken all of these and set the fractions up so that pi and pi cancel here, square inches and square inches cancel here. And what we get then, 6 times 117 divided by 63.61 gives us 11.03 peaches per 1 cobbler. Okay, so 11.03 we could say 11 peaches to make this this cobbler as opposed to the pie. Okay? So you set this up the same way that you set up dimensional analysis. You're going to do the area per one shape, the area per the other shape. Notice that these will always be reversed from each other. One will be like this, the other will be like this, so that you can cancel out the square inches, just like we needed to when we did dimensional analysis in the last sections. Okay? So let's see another example of this. So let's see. Yeah, so let's do this next one. Okay, so a ton of gravel will cover 100 square feet to a depth of 2 inches. How many tons of gravel would you need to cover a driveway 1/2 mile by 10 feet wide? Okay? So what we know is a ton of gravel per 100 square feet. We need to know the area of this driveway, right? In order to figure out how much gravel we're going to need, we need to know what the area of this is. And notice here that there are units. There's a unit problem. We've got a 1/2 mile by 10 feet. We want to change everything into feet so that we get something that compares to square feet, right? If we change this into miles, for one thing, 10 feet in miles would give you a really small number, so you might have some trouble with rounding. But then also, it wouldn't match up with this, and so you'd have to convert it back anyway. Okay? So let's change this into feet. So 1 mile is 5,280 feet. So this is going to be 2,640 feet, right? So 1/2 mile times 5,280 feet per 1 mile is going to give you 2,640 feet. Right, the miles cancel out. And so we've got 2,640 feet by 10 feet. The area of the driveway is going to be 2,640 feet times 10 feet. So 26,400 square feet. Okay, that's the area. Now we're going to combine that with our 1 ton of gravel per 100 square feet. So we've got 1 ton per 100 square feet. We're going to multiply that by the 26,400 square feet per 1 driveway. And we end up getting 26,400 divided by 100. The square feet cancel out. And so we get 264 tons per driveway. And so we need 264 tons of gravel to cover this driveway. Okay? Now, again, all kinds of problems come down to this. You need to find the measurement and make sure it's in the units that you need, and then combine it with any other rates that you have using this dimensional analysis technique that we learned in the last section. Okay?